So yeah, I'm going to talk now about the public trial that we did in the UK of low latency. This is sort of joint work with a number of people from R&D here and then a bunch of people across the BBC. So just the trial overview itself. It's BBC iPlayer, which is our streaming player that runs on TVs, set-top boxes, sticks, and then across the whole of the UK, and the kind of latency we're looking at is 6 to 10 seconds, which is basically broadcast latency. So the motivations really for the public trial were to try and deploy a low latency solution that would match broadcast latencies. And really for doing a trial, we wanted to do that so we could see how it behaved over commercial CDNs at scale, and understand how it behaved into real people's homes, and also how it then worked on real people's devices. So pre-trial research, we have been looking at Dash.js, trying to make improvements and make it more stable for low latency. We've had a number of things merged into the code. Then the next thing we did was looking at actual devices to see how they behave for low latency. So the key things we really needed was media source extensions, JavaScript based, and then we needed the fetch API because we're doing the delivery over chunk transfer encoding, low latency Dash, and we also wanted variable playback rate capability. Then we wanted to make sure that the CDNs actually performed, so we needed to make sure they did timely chunk delivery and also protected the origin. So the behavior is slightly different with CTE streams, so we wanted to ensure that was happening. So then we did some simulations beforehand, before the trial, and so on the left you'll see our iPlayer Live operating at a latency of, well, various latencies, but our sort of target latency that's usually set at is 12 seconds. And we can see that matches up on the low latency on the right around 5 to 6 seconds. So that's within our kind of area of interest. So here's a quick overview of the trial architecture. We got an on-prem encoder, which we developed, packager encoder, delay budget of around 3 seconds. It pushes chunks to the origin, and then these are delivered in chunk transfer encoding to the CDN, and then the client pulls those and then dumps metrics back to our metrics collector. Client buffer there is around 6 seconds. We've also got an access control module you'll see there, which that allows us to turn on and off the trial. So the trial kind of was running from 8 to 10 during the day and during the week, and then this also allows us to disable it if there's some kind of issues and so on. So this, so what happened was the clients had to be on the right kind of device. So as I said, we went through screening devices, finding the ones that would support the facilities we needed. And then this is a screenshot from the actual iPlayer bit of software that runs on our systems, client systems at home. And people can choose to set it into a sort of beta mode. It's basically a little flag they can tick. And about 1% of users have done that. And then if they're watching BBC Two, which is one of our sort of main channels in the UK, they would then, if on the right device, there are 21 device groups we put it out to, and that equates to about 500 model numbers when you take into account all different screen sizes and things. And then MSE devices represent about 25% of live viewing devices. So that's how the users would actually get onto the trial. So we made a number of enhancements to the media player. We developed a new kind of simplified catch-up algorithm that basically what it does is called step algorithm, and as you can see on the right, there's a little step there as compared to this nice smooth curve that is the default algorithm in Dash.js. So it basically will change the rate a lot, sort of while it's trying to get to that target latency. And we found that on a number of devices, changing the actual playback rate was not always a pleasant experience. So if you minimize that, then that was one thing that kind of helped things along. We then added low latency support for something called synthetic stalls, which is a detection mechanism in Dash.js, and then we also had to customize subtitles. We did a bunch of other additions for reporting. So these reporting collected metrics. So the metrics we collected were, we were using DVB dash metrics reporting, which provides for instantaneous throughput measurements and also for error reporting. Then we use CMCDV1 because that's what's built into the version of Dash.js we're using, along with the DVB dash metrics reporting. And then we had a bunch of custom metrics that we needed reporting. So things like playback rate and latency. And then our normal iPlayer reports some telemetry. That was also being reported, so then we could compare our conventional live streams that viewers were watching with our low latency ones. And then obviously CDN logs. So on the right, you can see an example where we can analyze a session in detail, looking at the buffer levels and so on. So the trial results. So looking at the actual actual latency we achieved. So this diagram, you've got the kind of yellow shaded area is that sort of 6 to 10 seconds of latency that we wanted to target. The blue line is the actual our BBC 2 HD DTT latency. And then slightly further out is our actual latency target on the trial. Then we split the devices up into devices that were capable of catch-up and devices that weren't capable. So you can see the catch-up devices stick pretty closely to that latency target, unlike the non-catch-up devices that you see fairly well out there. That's largely due to the startup effects. So the devices, they just don't start right at the leading edge. So that's why they're there, really. And then, of course, if there's any stalls, they're going to fall further out. So measuring the sort of performance overall, well, what we wanted to do here was we wanted to sort of see what the impact of low latency was on users' experience. So comparing really what happened in the session. So if there was what we did was we looked at sessions that had any errors or greater than 2 seconds of stalling as one sort of measure, and then a more tough measure of any errors, sessions experiencing any errors or any stalling as a sort of harder measure to then look at the comparison to sort of see whether it made it worse. So here what we see that with all devices, so going, it sort of shows you the green arrow points to better than conventional, yellow, the orange ones is worse than conventional. So we can see here that we're actually pretty much similar. We are slightly shifted over, but within the confidence intervals, we are basically not really making the experience any worse for users. If we look at the tougher measure, then we are seeing a small percentage increase in problems on the low latency sessions. And then we looked at the kind of breakdown between catch-up and non-catch-up devices again. And we thought originally that the non-catch-up devices would actually have a better experience, like sort of less stalling. But strangely, we actually saw that the non-catch-up devices seem to suffer more, which is kind of weird. But it seems really actually down to the devices themselves. So as I said before, basically low latency is pushing sort of buttons and sort of functionalities which we haven't really pushed before, and so that's really what explains some of that. So if we look at the actual top catch-up devices, we see a pretty good looking result there, so slightly better than live, which is nice to see there. Then if we look at connection type effects, we see that on cable, DSL looks pretty good. If we go to cellular, corporate, or satellite, LEO type scenarios, then we got a number of sessions there. We see significantly worse performance there. So key findings, really, we found that the best performing devices can really achieve latencies similar to broadcast, and without really increasing the effect on the actual sessions, which is nice to see. And then we also, I didn't show it here, it's in the paper, but we got average average video quality was about the same or better, actually. And then really it's down to the sort of device differences in terms of how things can perform, really. It's the same code running on all of them. So that's a sort of notable difference. And we see that we were seeing sort of strange things happening on startup, more stalling happening on startup, and also we're getting sort of very short stalls occurring. So this is something we're still looking into. And then as I said, we saw poor performance on other networks. So really, we've shown that we can sort of match broadcast fairly comfortably, and we're planning. This is sort of expanding trial. So now we want there was a small thing you might not have seen, but it's about 20,000 sessions we had, and we're hoping to basically scale that up, do some small sessions of quite high participants on a sort of broader approach to sort of understand some of these issues and see how it behaves at a larger scale. And we're also interested to look at some of the other approaches. So potentially we might be trying to look at things like different protocols, H2, H3. We're not really going to be moving to MOOC just yet, but that's something that we're sort of keeping on the radar anyway. But thanks. So I managed roughly around 10, slightly more. Okay.